Over the last few decades, robots have evolved from dumb, large, and dangerous machines into a variety of smart devices that use sensors and sophisticated controls to perform an ever-growing number of new applications. Today's robots are working in space, underwater, helping with advanced surgery, doing genomics and pharmaceutical research, assembling and testing consumer electronics, picking fruit, and rolling around from job to job. Tomorrow's robots may be taking care of us in our homes. I'm Brian Carlisle, CEO of Precise Automation. I have been designing robots for over 40 years, starting with the Puma robots in the 1970s, the Adept Technology robots in the 80s and 90s, and now a new generation of robots at Precise Automation. I was president of the United States Robotic Industries Association for 3 years and have served on a number of national boards. For many years, we tried to design robots to go as fast as possible in applications ranging from spot welding to candy packaging. As we developed better mechanisms and controls, robots could reach tool speeds of 10 meters per second, which is terrifying and very dangerous. Consequently, robots had to be fenced off from people, as any collision would seriously injure a person. This forced separation between robots and humans required a lot of engineering, floor space, and expense whenever someone wanted to install a robot. Historically, robots and people were never mixed together on the same manufacturing line. However, in many factory applications, most robots were not using their top speed. Many robot work cells have cycle times of 5 to 10 seconds, and the robots are moving at maybe 1 or 2 meters per second, not 10 meters per second. For a given robot, to cut the cycle time in half takes 4 times as much energy, and we don't want to run robots at speeds that are wasting energy. Consequently, a few years ago, we started designing a new generation of robots with the goal of trying to make them as efficient and safe as possible. It is anticipated that this next generation of robots will be able to work at human-scale speeds of 1 to 2 meters per second, but will also be able to bump into a person without injury. We call these new, safer robots collaborative robots. In this course, you will get an introduction to the wide variety of robots and robot applications that are under development. You will learn the safety standards that apply to robots and robot applications. You will learn how to design safe work cells for traditional robots, and then we will introduce collaborative robots. We will explain the new safety standards for collaborative robots and how to test these emerging new robots to make sure they meet these standards. We will also explain some key design techniques to reduce the collision forces from collaborative robots. These design techniques allow developers to make collaborative robots that can move a given payload faster while remaining safe in the event of a collision with a person. We will then show some simple and some very elaborate examples of collaborative robot applications to give you a feel for different collaborative robot work cells. Finally, we will provide some guidelines on designing collaborative robot applications. Welcome to Collaborative Robots.